Given the graphs below, this says determine if the graph represents a function. Part B says find the domain and range, and C says any symmetry with respect to the x-axis, y-axis, or the origin. So for I here, we have to determine if this graph represents a function. But all we have to think of here is that vertical line test. So if I draw a vertical line and it intersects my graph in at most one spot, then it's a function. If it's more than one, then that simply tells me that it's not a function. So I would have to write not a function because it fails the vertical line test. Done. So the next thing I have to find is domain and range. I had to put it together a little better. So now let's take a look at B. Find the domain and range. So if I look at the domain for this, that's all my possible x values. So that's going to happen only over on this side here, and including the 0. So it's going to go all the way left because this is opening that way. It's going to continue leftward, and the bottom also goes in that direction. So there's no way I'm going to go positive with that. So I would say the domain then is going to be parenthesis negative infinity, comma, 0, and I include the 0, so I use a bracket. Now the range is going to be my y-axis here, all my y values. And if you notice, because it's still going in an upward position, even though it's going to the left, and also in a downward position, even though it's going to the left, it's still going to continue all the way upwards and all the way downwards. So my range is going to be negative infinity to infinity. And then for part C, C says any symmetry. So now the symmetry means that if I pick a point on my graph, any point, and I reflect it over let's say I reflected it over the y, that would have to land back on my graph, and it doesn't for this one here. It actually is off the graph. So therefore, it's not symmetric about the y-axis. So let me try over the x-axis. So here's my x here. So if I take it the same distance on the other side, I'm going to end up back on my graph. And that would happen for every point I pick. So that tells me there that this graph is symmetric with respect to the x-axis. And I use an abbreviation for with respect to the x-axis. And one thing I do when I look at the idea of the origin, I just do what I told you guys before. I just kind of do a 180-degree rotation. And if I did, my graph would just end up on this side, which isn't the same as the graph I started with. So therefore, it's not symmetric with respect to the origin. So now let's take a look at number B. So for number B here, determine if the graph represents a function. So I can draw infinitely many vertical lines, and I can clearly see that I'm never going to intersect my graph in more than one spot. So it's always going to be at most once. So that tells me right away that it passes the vertical line test, which tells me for part A here that it is a function. And I'm going to write function because it passes the vertical line test. Now for part B here, part B says determine or find the domain and range. Now the domain is going to be all my x values, how far left and how far right we go. So if you notice, it's going to go all the way left, all the way right, and everything in between. So what I would say for this, I'll write domain first so you know what I'm talking about. Domain, negative infinity to infinity, And my range then is going to be negative infinity to infinity. So it's going to be the same because when I do my range, it's up and down. And you can clearly see that it's going to go all the way up and all the way down. And everything in between is actually covered with a portion of my graph. Okay, now part C. C says, is there any symmetry? Now, if I take any point, and let's say I flop it over the x. If I flop it over the x, that means I'm going this same distance and I'm putting it over here. And I can see that I'm not on my graph anymore. So that tells me that it's not symmetric with respect to the x-axis. Now I do the same thing in the y direction here. So I should be able to pick any point I want on my graph. So I'm going to pick this one here. And if I reflect it, that's going to be way over here somewhere, which is not on my graph. So therefore, it's not symmetric with respect to the y-axis. Now this one, if I did a rotation, if I rotated it, so if I took this piece right here and I rotated it around, it would turn into this piece here, which is actually still on my graph. And if I took this piece here and I rotated it 180 degrees, I would be back on this piece over here. So what that's telling me, because I can rotate this 180 degrees and it still looks like the same picture, the same graph, this would be symmetric with respect to the origin. Okay, now let's do the last one here. So for this last one, is this a function? So I can draw a vertical line and I can see that it easily intersects my graph in more than one spot. I don't know what it means to be easily, but it does. So therefore, it's not a function. So for part A, for this one, I would say not a function. Because it fails the vertical line test. Okay, now part B. Part B says domain and range. So for part B here, my domain here is going to be all possible x values. So I say how far left and how far right do I go? So anything on this line. And I can see that I start here and I actually go to there, and that's it. It starts at -2 and goes all the way to +2. That's where my graph lives. So that's going to be my domain. And I'm including those n values. So -2 to 2. Now for my range. Now for my range for this thing, that's my possible y value. So that's this way now. So the lowest I go looks like 1, 2, 3, 4, 5. So it goes down 5. And it goes up to 1, 2, 3, 4, 5, +5. So it's -5 to +5. And it includes those values. Oops. Now part C says, is there any symmetry? Now this one is interesting because if I take any point anywhere, and let's say I reflect it across the x, that's going to put me down here, and I'm still on the graph. And let me take that same point and reflect it across the y now. It's going to put me over here, and I'm going to be back on my graph again. So no matter what point I pick, it's going to reflect across the x and the y and still be on my graph. So it would be symmetric with respect to the x-axis and the y-axis. Now for part C, let's see if the origin works. What if I take this and I flip it 180 degrees? And if I do, this bottom here is now going to become the top. And guess what? It doesn't change anything. So this graph is actually all three of them. It's symmetric with respect to the x-axis, symmetric with respect to the y-axis, and with the origin. So this is actually all three.